I don't think I need to introduce you, Ken. Ken is going to continue the discussion on the semantics and data interchange. Is that a good summary of things? And are you audible?
There we go.
Okay.
Yes. Well, kind of a case study, the deployment of declarative markup, because we spend a lot of time at this conference thinking about the theories of declarative markup. I want to thank the organizers for accepting my proposal to talk about this slightly different subject. And I've got a number of slides here are copied from Prague. I'm just going to go over them quickly for those who weren't there. That's not my focus for today's presentation. Hello, for those who haven't, I haven't had the pleasure of meeting you yet before. My name is Ken Holman. I've been a programmer for 51.5 years now. Started in Fortran 4, but I have long been involved in the standards community and got involved in SGML in 1988, 89 timeframe, and have been learning from some of the people that are on the Zoom call here for decades. I'm really pleased to see that they're attending today, and thank you for attending today. And I've been very privileged to be able to share what I've learned with others and made a career out of that. And I'm now enjoying my retirement, traveling the world, participating in standards, and helping more people understand what's going on. So I welcome any questions. I welcomed the opportunity to talk more about the spec today with Stephen's questions, astute questions that he had, and I would welcome any input from anyone. But today, I'm going to present a case study of where declarative markup has been successfully deployed around the world, and how the issue, the problem of adopting declarative markup and how to get legacy systems to leverage declarative markup in a worldwide network, because we have to think about adoption. We have to think about how are our users going to leverage what it is that we are creating with our declarative markup. And I'm presenting this case study from the world of electronic invoicing. And now, as I'll explain you, we could do it in banking, we could do it in the medical world. The first case of this case study of multiple networks, the first of the networks was here in Europe. The Pan-European Public Procurement Online Project. Now it's just called Peppol, so they've changed the abbreviation into a word. And the Peppol project has a Netherlands installation called Simpler Invoicing. I don't know, hands up if you've heard of Simpler Invoicing here in this country. Ah, interesting, none. So the European Commission set out a requirement that government procurement shall be done electronically with the European Commission. So, and this is now law. And so how are we going to get thousands, millions of companies using electronic means to convey invoice information to the European Commission? And the architecture that was designed for Peppol is called the four-corner model. And I'm going to contrast the four-corner model to other network topologies. I have a full paper. My slide deck is only the figures from my paper. So I don't want to distract you with a lot of bullets. So please, you'll find these details in the paper. And the four-corner model network has successfully enabled companies across Europe to do electronic invoicing to the European Commission. And it was so successful that it didn't take very long at all before business to business was using the same four-corner model network, successfully exchanging documents across borders throughout Europe. This model has been adopted in Singapore, in Australia, New Zealand, Japan. There is a sister network having been created in the US, and I'm participating in that because of the cross-border interests with Canada and Mexico. I'm right now the only Canadian that's participating on that committee. And it is another instantiation of the four-corner model topology because of the demonstrated success in Europe of how this prevents disenfranchisation of people who need to participate in electronic commerce. And just to kind of look at a history of e-commerce. Before there was e-commerce, there was paper commerce. And when paper commerce became computerized, the choreography of business that the world has adopted over centuries got reified in data models that were designed by senders and receivers of these collections of information, an invoice, a purchase order, a waybill. And they were computerized by applications. Each application developer would have a different data model for their perception of how to satisfy the choreography of doing business. And there was no one data model. Every vendor had different business requirements, different task requirements that they came up with different data models. Their applications would convey the information to another user by printing off your invoice, sending that business document, which would then get scanned or data entry into the receiver's application, which moves the information into the receiver's data model if you didn't make any mistakes along the way. Changing 1,000 to 10,000 or something like that. So that was a challenge. And the receiver's application would populate the data model, and that would then satisfy the semantics of continuing the choreography, the dance of business between sender and receiver. So step one of computerization, print out the document and convey it. Well, step two is, hey, let's exchange an electronic representation of my data model, and I will give you my electronic invoice. But you see that I've depicted these two formats differently. There's an impedance here because the format of information created by the sender might not be compatible with the format of information expected by the receiver's application because it's a different company that sold the customer the package. So there's an impedance. There isn't a way to match the two. And this topology is the two-corner model. You've got the sender and the receiver, and they are trying to send. So one of the two has got to make a change. Usually the smaller guy and not the bigger guy. The Walmarts, the Costco's, the big companies are going to demand that you give them the invoice electronically in their format. And so the burden is on all of the suppliers having to change all of their systems to produce the electronic format for Walmart, and then do it all over again for Costco. And think of the cost, and think of the impedance, the burden on the invoicing company to have to match all of the formats of these 800-pound gorillas. And In Europe, they've solved that. So I'm going to present to you how that was solved in Europe. The evolution, though, didn't jump from the two-corner model to the four-corner model. There is, starting in the late 80s, the three-corner model. Let's delegate that impedance to some third party. And in government procurement, we would see this by prime vendors, guerrilla vendor companies with big staffs who would waltz into a government and say, we'll solve your problem, we'll create a system, it'll be a portal. Your government client portal will allow your your suppliers to send their invoices into our system, into our servers, and we will do you, government, a service of transforming that into the format that you want. And so, you know, the government's happy. They're going to get their invoices in the receiver's data format. But there's this third guy, this intermediary between the sender and the receiver. What if there are barriers for the sender to participate? What if the third party doesn't recognize the format that the sender wants to send? What if the third party is too expensive to use? There's a real opportunity and a real world evidence of disenfranchisation of companies who cannot participate in the three-corner model. Then there's a question of data sovereignty. Where is this data going to be residing by this third-party company? Is it a US service? Well, maybe then it is under the access of the Patriot Act, and people can go in and with reason will go in and could look at it and that kind of stuff. So the question of data sovereignty of this third party, that might be enough of a reason to disenfranchise someone from participating. So the governments loved this, and they buy the systems and they'd pay the prime vendors big bucks and they'd implement the portals. And they're still going on in some countries like Canada. And it's really unfortunate that this was embraced so well, because it has become entrenched, and it's very difficult to dislocate. And I'm sure it happened here in Europe, although I can't cite any examples. I'm sure this was the way to go. And the European Commission said, we can't have this. We need a network topology that is inclusive. We need a network topology that will not disenfranchise participants from being able to send us their invoices so that we can pay them. And the way, okay, hold that story, hold that thought, because back in 2001, we started the committee. It started, by the way, by John Bozak, the father of XML. I was lucky to be at the conference where John got the plaque. It says father of XML. John got this plaque, said father of XML. He's also the father of UBL, the Universal Business Language, an XML vocabulary of a core set of business semantics and onion skins of different document types that leverage the common library into different document types: purchase order, invoice, waybill, 91 different document types in UBL. And we XMLers said, we have solved the world. We have declarative methods of representing business information. Go out there, world, and adopt UBL, adopt XML. Because all you have to do is change your application to send XML, and all you have to do is change your application to receive XML, and you're up and running. And we sat and waited. And it got adopted in little places and all of that, but it wasn't the worldwide adoption that we're seeing today. because we didn't have the topology that the European Commission had built that solved this problem of getting the adoption of declarative markup. Now, I know it's going to sound obvious when I present the next slide to you, and I was worried about even basing a whole paper on this because the solution is so obvious, but I think it needs to be said. The four-corner model is where every participant has delegated the content mapping and the interchange to their trusted network representative called an access point. So every participant has an access point they trust, and they have a private connection, a private relationship with that access point. And it's the access point's responsibility to do the conversion from your format to UBL, the declarative platform independence, application independent syntax that then gets sent to your trading partner's network representative, who has a private relationship with your trading partner. And now I don't have to know what electronic system my trading partner is using, because his network representative is going to worry about converting UBL to their internal format. And now, yes, the problem still exists, but we've pushed the problem down to these network representatives. And before, we said, hey, we've solved the problem. We've created this XML. Your application has to do it. Instead, the application produces the data as it always does in a private connection with their trusted network representative, their access point, who then does exactly the mapping and the interchange that brings the XML, the UBL XML, to the receiver's access point, which in its private relationship with my trading partner will convert the data into a format that the two trading partners do not have to change their electronic systems at all. They do not have to change it. This was presented. This is one of the early diagrams from Peppol. So you have the European Commission, public sector institution with some interface to their access point. And me, a private company, I have some connection with my access point. And the only thing that defines the network is a set of specifications. There is no hardware. There is no prime vendor. There is no single point of failure. So now, of course, the prime vendors hate this solution because they're now out of the picture. And they have to, and then they have in Europe, they have adopted they have been pressured into adopting the four-corner model. But what they do is they provide their whole customer base with a four-corner model connection to the European Commission. So they still have a business case, but they still have to create this. They can no longer be in charge of the whole ball of wax. So the definition of Peppol, the Peppol network, the four-corner model network, is just a set of standards, a set of practices. A question I often get is, oh, what's it going to cost me to build this network for all of my users in my country? And the question did come up to me in the US. The US Federal Reserve Bank of Minneapolis had to solve this problem. And I told them there is no hardware, there is no upfront network, or even there is no network architecture. It's all built on the existing internet. And it is a peer-to-peer network where the peers adopt standards. Now, that doesn't mean there isn't the cost in specifying how the standards are to be used in your network. So there's a big cost in establishing this collection of standards and agreements and everything that is needed for a network. And the feds have been at it for 6 years now, and they're in market trials for the US network. Now, the European Commission, they started this in 2012, and they've long been running successfully on Peppol. And Singapore, Australia, New Zealand, Japan, they've simply adopted the Peppol practices. The Fed chose not to. The Fed went to the marketplace in the US, and the marketplace in the US said, no, we are not going to adopt something from Europe. We're going to create our own. Now, they have chosen the same UBL XML standard for the declarative markup between access points. So there is commonality there. The selection of which semantics are represented is slightly different. That's where I'm participating. But the interchange, the transport layer and all that are all using the same OASIS-based standards. And when your network is defined this way, without any hardware, then the network effect is really easy. Other access points servicing other companies can simply jump on the network by adopting standards. And it isn't going to cost the central authority any money at all in network hardware, because the definition of the network isn't done in hardware, it's done in specifications. That's what defines the network. There are now hundreds of access points in Europe servicing thousands of companies across Europe, successfully interchanging their invoices with the European Commission and with each other. And Peppol has now evolved to include purchase orders and a number of other documents, not all 91 documents, but a few other documents have already been adopted. They're already looking in the US at what they're going to do after they do the invoice. So now, when one person joins, they immediately have access to everyone else on the network without having to know who is there. And for everyone else on the network, they can all access the new participant instantly because they've been qualified as meeting the standards specified. So the network operator has to have some kind of validation process, adoption, certification process. So a certified access point, once they join and they control the access to the network through the control of public keys. So an access point can only converse with another access point that has a public key issued by the common authority that governs the whole of the network. So they've got security in place. They're using AS4 for the communication, peer-to-peer communication. Notice there is no central storage. There is no repository of your documents. There's no question here of data sovereignty. It is a peer-to-peer network. It is not a centralized network. And the flexibility is wonderful, because what if this access point here goes out of business? What is this private company going to do? Just simply buy the service from another access point, and they're up and running again. And the search for a trading partner's network representative is done in real time. So if I have one access point in the morning and I have another access point in the afternoon because something happened, there's going to be no break in my flow of my information. So this topology really supports the use of a declarative standard between them all, because that standard, that declarative markup, is independent of all applications. It isn't owned by any vendor. It isn't under anyone's control. It is an ISO standard because OASIS took UBL to ISO as a PAS submission. And now the participants are protected because they can simply find a new access point, and they could, and also you can have different access points for different document types, because perhaps I have one ERP system that handles orders and one system, legacy system, that handles invoices. And so I'll have different access points for those two systems. And when in the communications interchange that establishes the peer-to-peer connection, it correctly finds the peer that is needed for the document type that you're dealing with. And this has proven a very flexible topology. The oil and gas industry has adopted the four-corner model in their world. It's tremendous. And the communities have banded together to create the GIF, the Global Interchange Framework, which is a set of specs that specifies UBL, specifies AS4, specifies the OASIS standards that are used in order to interchange. So all of these are now instances of this GIF or GIF network class, network topology class. And what this means is I implement, I identify, or perhaps I am my own access point. I identify my network representative, and they handle everything on my regard, and my data in its raw format gets transformed by them into UBL. I can now send my invoice to buyer 1 and buyer 2, even though they have different ERP systems with different data models. That's fine, because everyone's using declarative markup at the network layer. And if you think this can be deployed, this really can be deployed anywhere where you want to have open interchange, open participation. Think of medical opportunities here. I know that in Norway, they're experimenting with medical information. They've already done some banking information in Norway across the four-corner model network. There's big adoption of this in Norway in particular. And underpinning it all is I am going to take a quick look closer into the four corners. So the corner 1, say that's me. I want to send my invoice to my client. And so my ERP system generates my invoice data in my system's format, and my network representative takes that and through application code creates a UBL XML document. It might be using some subset of the humongous UBL schema specification in order to create that. Somehow it creates its code. It should, doesn't have to, but it should check the data it creates against the community's specification of values for the UBL model. And I'll talk a bit more about UBL later. Passes the UBL through the transport mechanism. All of these networks are using AS4 for security reasons. The corner 3 receives the UBL document. It checks it against the full UBL schema, untouched, the full untouched UBL schema, and then checks against the community set of business rules. Now, because this check is being done, that's why corner 2 should be doing the same check, because it is violating one of the network agreements to send data that won't conform here. And then the data is passed to the application code, which goes to the ERP system. So let's focus in on corner 3 a bit. So we have the published UBL schemas. We have, in this case, the BPC, the US network set of schematrons that get transformed into XSLT. And that is a GitHub project. I'm pretty sure I've got the link in the paper. If not, ask me if you're curious. And the XSLT processor says whether or not the values are valid. If there's a schema error, SV, schema violation. And that goes back in a UBL message to corner 2. So corner 2 can say, hey, I must have done something wrong, because if corner 2 did everything that it's supposed to do, it would not get a schema validation error. It also would not get a BV, a business validation error. I'm hesitant to use the word business rules, because business rules to me live in the ERP system. They don't live in the transport layer. So I have been pushing in the BPC project to call these data integrity constraints, as opposed to business rules. So they're data integrity rules, not business rules. But this is a legacy from the Peppol project to call it BV, because they didn't ask me, so I didn't get the opportunity to say that. So yes, so if corner 3 finds that the XML meets all of the requirements according to the network specifications, it can then safely convert all of the information into the data format required by the ERP system of my trading partner. And my trading partner gets my invoice. And it's quick and it's secure. And it's a peer-to-peer network. So there's no single point of failure. Tickety-boo. And that's how we got a declarative markup language like UBL adopted worldwide. And we didn't put the onus on the actual trading partners. The Peppol designers created this. Now the four-corner model, of course, already exists. Think about the postal network. Canada Post. I live in Ottawa. If I want to send a package to the Czech Republic, I want to send it to Yurka. I don't know how the system works in Czech. All I do know is this thing called an address, and so I write a Czech address on my package. I give it to Canada Post. Canada Post just looks at Czech and says, "Okay, I know what to do," because there are international standards for interoperating between postal organizations, and Canada successfully sends the package to the Czech Republic. Now, the Czech Republic gets the package. It has a private relationship with Yurka, so it's going to ensure, according to the network agreement, that it will deliver its package to. So there's the four-corner model. I have a network representative, Canada Post. Yurka has a network representative, the Czech Post, and the thing happens. Cell phone networks are another great example of a four-corner model network, because I don't need to know if you're using an iPhone or if you're using 4G or LTE or whatever, and you don't have to know what I'm using, but my network representative uses an international standard to get the data to your network representative in your private connection that conveys the data to your phone. So the four-corner model network isn't new, but it was newly applied in 2012 by the designers of Peppol to XML, and it has been wildly successful. So that's the essence. Well, I could talk now a bit more about UBL. UBL is a large family of document types. It has a whole set in the area of procurement, the pre-award, determining who's going to supply me, making an order, dispatching. The information engages a whole bunch of documents in the transportation world. Once the document, or once the items are received, that triggers an invoice, which is the banking world. Now, UBL is not trying to step on anybody's toes, and so ISO 20022, The banking standard is used in the banking world until you get the remittance. And then I might need to check for any replenishment, and I might need to order again. And so this is circular. It's 20 years in establishing this large family. 2.4 is on its way. The 2.3 has 91 different document types. And in retrospect, the work that we did in UBL meshed well with two standards. Well, actually, the retrospect is only with 14662. This is early 90s. And this is something Stephen brought up earlier about the separation of semantics and syntax, the meaning from the actual representation. And back in the 90s, 14662 distinguished the business-oriented operational view from the functional services view, where you have the business environment in which I'm working, the scenarios between trading partners, the roles of the people in those trading partners who are exchanging information bundles. Notice how abstract that is, a bundle of information. It doesn't say anything about the syntax. Where the syntax comes along is in the functional services, where the rubber hits the road, because you need user data, you need octets that represent the information bundles that can be interpreted by the receiving party. You need a choreography, a workflow between the parties, and you need transport in order to securely get the information to the other party. And looking at the table of contents of UBL, sure enough, we had already recognized this separation in the way we arranged our own documentation. Section 2 is all semantics. What do these objects mean? Sections 3, 4, 5 is the syntax. Now, how do you get from the semantics to the syntax? And that's through a concept called naming and design rules. And in OASIS, we gave this name to this process of converting the abstract business objects into concrete syntactic exchange structures. And that requires an abstraction of these business objects for the information bundles. And we chose a UN CFACT specification called CCTS. This is part of EBXML. We're using version 2.01, where business information entities, BIEs, are pointers to other ABIEs, or a collection of basic information which is made up of data types, which are associated with core component types. And these this ends up being a hierarchy which maps well to XML, maps well to JSON, and we have since created a JSON serialization of UBL from CCTS. We did not convert our XSD into JSON schemas. I specified a serialization of CCTS to JSON schema and did that independently. So when you press, when a committee member does a GitHub commit and push of their changes to the model, out come both XSD and JSON schemas automatically with their changes reflected. As I said, there's 91 document types in UBL 2.3. You are not obliged to implement all of them. Typically, a client will, or a community will choose some subset of document types. They might even have additional document types that use the library. The abstraction is very handy. The committee does its work in a Google spreadsheet. And when you do your commit, my processes go and fetch the content of the spreadsheet and create the schemas. Now, this is describing BIEs, ABIEs, and BBIEs, and down here ASBIEs. So this is all CCTS. This is not XML. This is, so it's a level of abstraction above the XML, and the JSON, and we just serialize this following the naming and design rules. As I said earlier, it's typically a 2-pass validation because in the UBL committee, we wanted to govern how the information was organized, but we knew we could not tell people how to use UBL or what values to use in UBL. And so we separated the committee responsibility from the community responsibility. And it's up to the community to decide what values are in the structures. So use the schemas to make sure the information is in the right place, and then use the schematron or some kind of secondary process. Most of the users are using schematron in order to check that the values are correct in those correct locations. We, as a committee, knew that we wouldn't be able to satisfy everyone's requirement. So from day one, we've had an extension capability in UBL. Up until recently, you could only extend a UBL document at the document element. But now you can introduce UBL extensions at any branch of the tree. So you can now contextualize your extensions for any information element in UBL. It's proved to be very helpful. Put this all together. This is a diagram that I drew to summarize the Peppol perspective of the world. And you can see on the left, we have 14662, the open EDI reference model, separating the business operational view from the functional services view. I'm the author of part 20 of 15944. I've spent 31 years in ISO committees. And this documents the typical kind of separations of responsibilities at the BOV and the FSV level. You can see the role of section 2 of UBL defining the information bundles and 345 defining the user data. There is a SEN business interface interoperability or business interoperability interfaces set of technical committees. EN 16931 is a SEN standard of profiles of scenarios and roles with a syntax binding. Now, it's too bad they use the word syntax there, because what they're actually binding to are the UBL business objects, and it's UBL doing the syntax. But they didn't ask me. So this is profiles and syntax binding as part of SEN BII, which is all done in a legal framework and a set of business rules described by the Peppol BIS, Business Interoperability Specifications. And it's these BIS that have been adopted by the European Commission, by Singapore, by Australia, New Zealand, by Japan. And the US is doing all of this from scratch for their own BPC network. They're allowed to, but it's all using the same base standards. And I'll leave this slide up. Now I do have a minute and a half to talk about an annex that's in the paper that I gave you, because I lied a little bit when I said there was zero hardware here, because there is one piece of hardware needed, and that is a DNS server. Because how do you find your trading partner's network representative? And no one challenged me on that, but so think, this is a great diagram from the Amazon website that I've cited here. When you have a browser and you ask for a domain, you need the IP address for a domain. It goes to the root server, you get the name server for .com, which gives you the name server, for example, which gives you the IP address, and then you go to the page and you get it. That's how a web page works. In Peppol, they did the very same thing for finding your trading partner's network representative. And this is why it works in real time. Because as long as they update the internet's DNS, now your piece of hardware for your, if you're a network representative, you need a name resolver down here for all of the names in your domain. And you manage that. Yeah, it does a hash on the customer identifier in order to make it compatible with with the references are compatible with network addresses. And so corner 2 has to find out who corner 3 is using corner 4's reference ID. And this server delivers that. And now corner 2 can go to corner 3 based on based on the document type and the process identifier, and actually successfully get all of the information it needs to send the document. But that's just an annex. And I hope this has opened your eyes to a real world technique for getting large communities to really adopt and leverage declarative markup. Thank you. Yep, behind you, there's a microphone.
Thank you. What does it look like when the UBL specification changes? Like, how are all the network participants notified, and what's the process look like for that?
Yep, it is an adopted precept in UBL of backward compatibility. So every instance of UBL 2.1 is a valid instance of UBL 2.3. So there will never be a violation. This was put into the design of UBL, or the strategy of UBL, to ensure that you could do network migration in a piecemeal basis, where as long as you were in the network, you could still successfully exchange old documents until everyone was had migrated their systems to 2.3, and then you could collectively adopt new features. But you would never crash your network by introducing a backwards incompatibility. Now, that's at the committee level. It's up to the Peppols to decide whether they're going to adopt more of UBL, never less of UBL, but they're to adopt more of UBL that comes up. So there's no risk to the network definition. Guaranteed to be backward compatible. Okay, no questions from the community? Oh, I don't want to take time from Liam, so.
No, that's okay. Actually, I have a comment. I was at some point asked by being in the publishing company that I work for, by financial guys to implement Peppol connection.
Yes.
And I saw the UBL spec, and I got a big headache.
Oh, yes, yes.
And then later they said, no, we're going to do it differently. And probably it's that they realized it wasn't our task to insource the connection, but
yeah, you can choose to insource it.
Yeah.
But
yeah.
you can choose to delegate it.
Yeah, in this case, delegation was a better alternative.
Yep. Yeah.
Thank you very much, Ken. Oh, one question. Sorry.
Oh, sorry.
Yeah,
Thomas
yes.
Hillman asked, you'd have to be a right SAP to use a service like that. That was on one of your first slides where you showed the first or second corner. And well,
yeah. So
after the X.
After the X.
Yes, this one, the intermediary data store.
Well, SAP is both an ERP system and a service. So because there are companies that will accept documents from SAP as the store, but SAP customers have to have adopted this topology in Europe in order to do business, and there are of the hundreds of access points in Europe, I'm sure most of them would support SAP in some manner.
Well, thank you very much, Ken Holman.